Dear students, under the lecture series on complex analysis, here we have problems of the type where we have to express each of the following functions in the form of u of x comma y plus I v of x comma y. That is, functions of complex variables are given here. Now, we have to separate the real part and imaginary part by finding u of x comma y and v of x comma y for these functions. So in order to solve such a problem, first of all we shall write the complex variable z. That is, we have to put the complex variable z to be equal to x plus iy. So we have already seen that a complex variable can be written in the form x plus iy, where x is the real part of z and y is the imaginary part of z. Now here the function of the complex variable is given as f of z equal to z square. So f of z is equal to, what is z? It is x plus iy. So let us replace it by x plus iy the whole square. Now this can be expanded by using the formula a plus b the whole square, which is equal to a square plus 2ab plus b square. So on expanding, here x will be treated as a and iy will be treated as b. So a square, that is x square, plus 2 multiplied with a, which is x, multiplied with b, which is iy, plus b square, that is iy the whole square. Now this can be further written as x square plus 2xyi. That is, I have just combined the variables and I have written 2xy and I have written I here. Plus this iy the whole square can be written as I square y square. But we know that the value of iota square is equal to negative 1. So on replacing this I square with negative 1, we get this to be equal to x square plus 2xyi minus y square, because the value of I square is negative 1. So on replacing I square by negative 1, we get minus y square. Now let us combine the real parts and the imaginary parts. Now if you see, x square minus y square is the real part. That is equal to x square minus y square, because they are independent of y, I. So since they do not have I in them, they are the real part. Whereas this term has I in it. So the imaginary part will be 2xy multiplied with I. So therefore, we have written the function of a complex variable f of z equal to z square in the form of real part plus the imaginary part. That is, this is u of x comma y, which is a function of the variables x and y. And similarly, this will be v of x comma y. So we have written it in the form u of x comma y, I multiplied with v of x comma y. And hence we have expressed the given function in this form. So we have separated the given function of a complex variable as real part and imaginary part. Now let us do another problem of the same type. Now here we have another problem, w is equal to z cube. So as in the similar way how we did the previous problem, in the same way we have to replace the value of z to be equal to x plus iy. Since we know that z is a complex variable, it will be of the form x plus iy. So therefore w will be equal to z cube. So x plus iy the whole cube. We know that a plus b the whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. So by using this formula over here, x will be treated as a and iy will be treated as b. So a cube, we will be having x cube plus 3a square b. So 3a square will be x square and b will be iy plus 3a, that is a is x here. So 3x b square. So it will be iy square plus this is b cube actually. So b cube. So b is iy the whole cube. So now we shall further simplify it. So this will be equal to x cube plus we will combine the variables. So 3x squared y, and we will write the imaginary part here, plus we know that the value of I square is negative 1. So this term becomes negative 3x y square, because I square y square will have I square is equal to minus 1, and so minus 3x and this y square plus I cube y cube. But we know that I cube is actually equal to I multiplied with I square. So that is equal to I multiplied with, what is I square? It is minus 1. So finally I cube will be minus I. So therefore this is further equal to x cube plus 3x square yi minus 3xy square. So this I cube has to be replaced by negative I. So minus I y cube. Now we will combine the real part and imaginary part. So those terms independent of I are the real part. So we have x cube here. Here you have I, so you need not consider it. And then you have negative 3xy square. And you have I here. So therefore the real part is x cube minus 3xy square, and the imaginary part will be these two terms. So while combining, we can write it as 3x square y minus y cube, and we can take and write I separately. So therefore it has been written in the form u of x comma y plus I multiplied with v of x comma y, where u is a function of x and y, and v is also a function of x and y. Therefore we have separated the real part and the imaginary part. We have third problem under this type. It is given as w equal to 2z bar square plus 1. So now here z can be taken as x plus iy, since it is a complex variable. So therefore w will be equal to, now here we have 2z bar square. So what is z bar actually? It is equal to the conjugate of z. So z bar is the conjugate of z. So conjugate of z gives us x minus iy, that is the imaginary part turns out to be negative. So that is the conjugate. So w is equal to 2z bar square. So this is z bar, x minus iy. So it will be x minus iy the whole square plus 1. Now again we have to expand this by using a minus b the whole square formula, which is equal to a square minus 2ab plus b square. So where a will be x and b will be iy. So this will be equal to 2 multiplied with x square minus 2ab. So minus 2. A is x, b is iy. And then plus b square. So plus iy square. So that will be further equal to 2 multiplied with x square minus 2xyi, and I square is negative 1, so minus y square. So combining the real part and the imaginary part, we will be getting this as, actually this plus 1 I have to write here. So plus 1, similarly it comes here also. So remember 2 multiplied with x minus iy the whole square is what I have written here, and this plus 1 has come here. So next step will be, this 2 can be multiplied throughout inside. So it will be 2x square minus 4xyi minus 2y square. And then this plus 1. Now let us combine the real part and the imaginary part. So the terms with independent of I gives us the real part. So if you see 2x square minus 2y square plus 1. So that gives us the real part. So 2x square minus 2y square plus 1 is the real part, and the imaginary part is minus I 4xy. So when you say the real part and imaginary part, you must say that along with the sign also. For example, here u of x comma y is the real part, which will be 2x square minus 2y square plus 1. And v of x comma y will be the imaginary part. In that case, you must say the imaginary part as negative 4xy. So you should combine this sign also. When it is positive, we write just as it is 4xy. But when you have a negative sign, you should surely mention it. So that comes under the imaginary part. Only this I iota gives, that is the terms along with I gives us the imaginary part. So we have another question under this topic. Now w is equal to 1 plus 1 by z. So what is z actually? It is a complex variable, so it will be taken as x plus iy. So w will be equal to 1 by z. So 1 by x plus iy. So whenever you have a complex variable in the denominator, you have to get rid of the imaginary part in the denominator by multiplying and dividing the term with its conjugate. So what is the term in the denominator? It is x plus iy. So what is the conjugate of x plus iy? It is x minus iy. So you have to multiply, okay, and divide by x minus iy in order to simplify this. So that will be equal to, the numerator will be x minus iy, and in the denominator if you see, you have x plus iy multiplied with x minus iy. It is of the form that is a plus b multiplied with a minus b. So what is that actually? A plus b multiplied with a minus b is equal to a square minus b square from the algebraic formula. So using this, here you have x plus iy, that is a plus b, and here you have x minus iy, which is a minus b. So when you multiply those two, a square first you have to write, that is x square, and minus b square, b is iy, so iy the whole square. So further, this can be written as x minus iy divided by x square. We know that I square is minus 1. So minus into minus becomes plus, so it will become plus 1. And then you have y square. Now, these terms in the numerator can be separated. So, this denominator is common for both the terms in the numerator. So, x by x square plus y square minus I multiplied with y by x square plus y square. So, we have separated the real part and we have separated the imaginary part. So, what is the real part here? U of x comma y, which is equal to x by x square plus y square. And what is the imaginary part? It is v of x comma y, which is equal to, along with the sign you have to take it, so it will be negative y divided by x square plus y square. So we have completed this problem. So now here we have another problem, which is w is equal to z by 1 plus z. So it can be, we know that z is a complex variable, so z is equal to x plus iy. So therefore w will be equal to x plus iy divided by 1 plus z. So 1 plus x plus iy. Now if you see, we have I in the denominator, and what I have told you, whenever you have I in the denominator, you should multiply and divide the term with the conjugate of the denominator. Now what is the real part here? 1 plus x, and the imaginary part is y. So what will be the conjugate of this denominator? It will be 1 plus x, the real part, minus iy divided by 1 plus x minus iy. So the conjugate of this is 1 plus x minus iy. So we are multiplying and dividing it by the conjugate. Now we can multiply these two terms, that is x will be multiplied with 1 plus x. So it will become x into 1 is x, plus x multiplied with x is x square, and then minus I, x multiplied with y is xy. Now the term iy will be multiplied with this. So plus, with 1 when we multiply we get iy, with x when we multiply we get ixy, and plus into minus is minus. I multiplied with I is I square, and y multiplied with y is y square. And in the denominator, if you see, it is of the form a plus b multiplied with a minus b. So what is a here? A is 1 plus x and b is y. Iy. So therefore it can be written as a square minus b square. So what is a square? 1 plus x the whole square minus b square is iy the whole square. So that is equal to, further, now in the numerator we can see that plus ixy and minus ixy gets cancelled, and we are left out with x plus x square plus iy, and then this I square becomes minus 1, and minus into minus becomes plus, so plus y square divided by, and in the denominator we have 1 plus x the whole square, and I square is minus 1, minus into minus it becomes plus, and y square. So this is what we have in the denominator. Now we can separate the real part and imaginary part, that is x plus x square plus, okay, this x square plus y square plus iy in the numerator, and in the denominator 1 plus x square plus y square. Now if we separate the real part and the imaginary part, this denominator is common to both the terms in the numerator. So that will be equal to x plus x square plus y square divided by 1 plus x the whole square plus y square. This is what we get. And then plus I multiplied with y divided by 1 plus x the whole square plus y square. So therefore the real part is this u comma x, u of x comma y, and the imaginary part is v of x comma y, which is this. So we have separated the real part and the imaginary part. Here we have the next problem, that is w is equal to z multiplied with z bar. So what is z? It is actually x plus iy, and z bar is the conjugate of z, which is x minus iy. Now here w is given as z multiplied with z bar, which is equal to, so z is x plus iy and z bar is x minus iy. Now let's just multiply these two. So it is of the form a plus b multiplied with a minus b. So it can be written as a square minus b square. And so that will be equal to a is x. So x square minus b is iy. So iy square. So that is equal to x square minus I square y square. We know that the value of I square is equal to negative 1. So that is equal to x square. So this is negative 1, minus into minus will become plus, and we have y square. And we see that this term does not have an imaginary part. So u of x comma y is equal to x square plus y square, whereas v of x comma y does not exist here, so that is equal to 0. So we are done with this problem. So we have one last problem under this topic, which is w is equal to z plus 1 by z. We know that the value of z is equal to x plus iy, since it is a complex variable. So now here w will be equal to x plus iy plus 1 by x plus iy, because we have 1 by z over here. Now we can take the LCM. So what will happen? The LCM will be x plus iy, and when you multiply this here, we get x plus iy the whole square. It gets cross multiplied with this term, and then plus this 1. So this can be expanded now by using a plus b the whole squared formula. So that will be further equal to, I will write here, so it is x square plus 2xy I, and then plus I square y square plus 1 the whole divided by x plus iy. So this 1 is what I have written here. So x plus iy. So further this can be written as x square, and we know that I square is minus 1, and so it will be minus y square. So I can just combine the real parts. So minus y square and this plus 1. So this gives us the real part, plus the imaginary part in the numerator is 2xy multiplied with I. Still we have the denominator x plus iy. Now we see that the denominator is a complex variable. So we have to multiply and divide by the conjugate of the denominator. So the conjugate of x plus iy is x minus iy. So we have to multiply and divide with the same. So now when we multiply x minus iy with this term, so that will turn out to be, now this x gets multiplied with each of the terms in the numerator. So we shall multiply each of the terms with x first. So x squared multiplied with x is x cube minus xy square, and then plus x, and here when you multiply we get 2x square yi. In a similar manner, minus iy gets multiplied with each of the term in the numerator. So when we multiply with this, we get minus I x square y, and then minus into minus plus I y cube, and then plus into minus is minus, and 1 multiplied with iy is iy, and then finally this minus iy has to be multiplied with this also. So plus into minus is minus, and then I multiplied with I gives us I square, and 2xy multiplied with y gives us 2xy square, the whole divided by x plus iy multiplied with x minus iy. Okay, because we have multiplied this x minus iy in the denominator, these two terms gets multiplied. So further this will be equal to, we have to be very careful with the calculation. So this is x cube minus xy square plus x, and then this remains as it is, so 2x square yi minus I x square y plus I y cube, and then minus iy. The change comes here, that is we have I square over here, so it is minus 1, minus into minus plus 2xy square, and then divided by this term is like a plus b multiplied with a minus b, so it will be x square minus I square y square. Now we will gather the real part and imaginary part in the numerator. So if we do so, that will be equal to, first we will gather the real parts. So this is independent of I, this, and these terms have I except this term. So it will be x cube minus xy square plus x, and the last term 2xy square, which is the real part, and imaginary part is plus I we will take. So it is 2x square y, and then minus x square y plus y cube minus y, the whole divided by, now this I square is equal to minus 1, so minus into minus becomes plus, and so the term becomes x square plus y square, and so that is equal to, now if you see minus xy square plus 2xy square, so it becomes 1xy square, because 2 minus 1 is 1, so it will be x cube plus x plus xy square plus, now here also 2x square y minus x square y gives us x square y, so I multiplied with x square y plus y cube minus y, the whole divided by x square plus y square. Now separating the real part and imaginary part, this denominator is common to both the terms, and so you can write it as x cube plus xy square divided by x square plus y square, plus I multiplied with x square y plus y cube minus y, the whole divided by x square plus y square. So therefore the real part is u of x comma y, which is this, and the imaginary part is v of x comma y, which is this term. So I hope you would have understood this concept as of now. Kindly go through each of the problems step by step. Thank you.